Welcome to the Algebra 2 End of Unit 5 Test Practice Problems. These practice problems were picked because they cover all the skills you'll need to do well on the End of Unit 5 test. Describe a way to transform each graph so that it better matches the data. So what they're saying is you need to transform the blue line so that it fits the data plotted by the green points. The best way to do this is pick points on the graph right at the crosshairs. So we know that this point is at -1, +4. And then you look for the corresponding point on the green dot data points. And that would be right here, where x is 2 and y is 6. And then you're trying to describe how you would move the first point on the blue line to get it to where the second point is on the green data points. So we can see that we need to go from x equals -1 and shift right 3 units to x equals 2. So we're going to shift right 3 units. Then we can see to go from y equals 4 up to y equals 6, we need to shift up 2 units. And that's how we would complete A. Now we're looking at B. Again, I want to find somewhere right on a crosshair that I can identify a good point with the green dots that would also be right on the crosshair. So I'm going to select this point at x equals -1, y equals -1, and I'm going to identify its corresponding point right here at x equals +1, y equals 0. So now if I want to describe this, I can see that I need to shift right 2 units. And then I can see that I need to shift up 1 unit. And in the bottom left, we're looking at C. Notice the blue graph opens upward, but the green data points open downward. So the first thing we need to do is reflect across the x axis. This will turn the blue line upside down so that it opens in the same direction as the green data points. Then we're going to identify the vertex right here at the origin, 0, 0, and then the origin of the green, or the vertex of the green data points is right here at +2, +5. So we need to shift right 2 units. And from there, we need to shift up 5 units. If you have any questions about how I answered this practice problem, please use class time to ask for clarification now so that you are set up for success for the test. Describe how to transform the graph of f of x equals x squared into the graph of g of x equals 4 times the quantity 3x minus 1 squared plus 5. Check your response by graphing f and g. So first, we want to look at f of x equals x squared. This is the graph of a parabola opening upward with the vertex at the origin. We're going to break down the g of x and see what each number does. First, we have 4. 4 is outside the parentheses, so this multiplies and makes the y value 4 times larger. So 4 is a vertical scaling. To stretch 4 times taller. Next, we have the 3. 3 is inside the parenthesis, multiplying the x. So 3 is a horizontal scalar or scaling to make g of x 1/3 as wide. Next, we have the minus 1. This minus 1 is inside the parentheses, so this is a horizontal shift. And that horizontal shift is 1 unit right. And last, we have this plus 5. That plus 5 is outside the parentheses, so it's adding 5 onto the y value. So this is a vertical shift, and that shift is 5 units up. Now that we've made our predictions about what each number will do to the original graph f of x, let's take a look. So I've used the Desmos.com calculator, and I'll point out the parts. Remember that we said the 4 was a vertical scalar. So the red line is the original f of x parabola, and now you see the blue one has been stretched 4 times taller. We said that the 3 was going to crush the parabola horizontally. It was going to squish it down by 1/3, or make it 1/3 the size. And that's why you see this really skinny parabola instead of the original wider parabola. Then we said the -1 meant a shift right by 1. And originally, this was shifted by 1, and the vertex would have been here at 1. But this 3 horizontal scalar has now squished that down from 1 down to 1/3. And then the final part was the 5. We said that would shift it up 5, and that's exactly what we see here. Instead of the vertex being at 0, it's up here at 5. So this is what it looks like, and this just shows that all of our predictions were correct. If you have any questions about how I answered this practice problem, please use class time now to ask for clarification before we take the test. Here are graphs of two functions, f and g. The function h is defined by h of x equals f of x minus g of x. Number 1. For which values of h of x equal to 0? Explain how you know. So, for number 1, we have h of x equals f of x minus g of x, but we want that to equal 0. The only way that happens is if f of x equals g of x. To subtract one number from another and get 0, the two numbers must be the same. So that's going to happen where the lines cross each other. So it happens when x equals -2, and it happens at the origin when x equals 0. Number 2. For which values of x is h of x less than 0? So h of x is less than 0 when f of x is less than g of x. If I have a smaller number minus a larger number, my answer is going to be negative. So what we need to do is find out when f of x is less than g of x. f of x is the black line, so it's less when the black line is below the blue line. So between -2 and 0. So we would say -2 less than x less than 0. So we don't include -2 or 0 because those points give us 0 for an answer. But in between those 2 points, where the black parabola goes below the blue linear graph, that's when it would be less than 0. And h of x is greater than 0 when f of x is greater than g of x. Because if I have a larger number minus a smaller number, my answer would be positive. And that is everywhere that the black parabola is above the blue line. So we would say negative infinity to -2 and 0 to infinity. And notice we used parentheses for all of this because we are not including any of these numbers. It's impossible to include negative infinity or infinity because they are not set numbers. And we are not including -2 or 0 because those values made it equal 0. And then number 3 wants us to sketch a graph. Well, we already know that the points where they cross are going to equal 0. And we said that in between -2 and 0, we were going to be negative. So we can connect them here. And then we said both directions after that would be positive. So we could draw the line going up and the line going up. And this would be h of x. If you have any questions about how I solved this practice problem, please use class time now to ask for clarification before we take the test. In the table, we have the function f, which gives Claire's height f of t above the ground, in feet t seconds after starting her descent from the top of the original Ferris wheel. Today, Claire tried out 2 new Ferris wheels. The first one, whose height is given by the function p, is half the height of the original and turns at the same speed. The second one, whose height is given by the function r, is the same height and has the original but turns at twice the speed. Number 1, fill in the table for functions p and r. So t is the time, f of t is the height. Now we have P of t. This is half the height, but the same speed. This is a vertical scale. It is squishing this down by half. So we can take the height of the original one and we can do it in half. So instead of 212, it would be 106. Instead of 181, it would be 90.5. Instead of 106, it would be 53. Instead of 31, it would be 15.5. And at 0, it would still be 0. Because it's half the height, but it's the same speed. Then we have r of t. This is the same height, but twice the speed. So this is a horizontal scale. So if r of t is the same height, but twice the speed, then 2 times 0 is 0, so the height is still the same, 212. 2 times 5 is 10, so we need to go down to where time equals 10, and the height was 106. Now we would say 2 times 10 is 20, so we go down to 20, and we see that the height was 0. Now we would say 2 times 15 is 30, but we don't know the height at 30. So we have to put a question mark here. And we would do 2 times 20 is 40, but we don't know what the height was at 40, so we're also going to put a question mark in this box. Number 2, explain why there is not enough information to determine r of 15 and r of 20. To find r of 15, we need to know f of 30. And we don't to find r of 20, we need to know f of 40. And we don't. And number 3, express P and R in terms of F. So P of T, we said this was a vertical scaling. It's half the height. So we're going to say that's 1/2 F of T. On the other hand, to find R of T, then we needed F of 2 times T because it was going twice as fast. And this is what we did. To find p of 0, we multiplied f of 0 times 1/2 to get 106. To get r of 0, we multiplied 2 times 0 and found out the height was 212, and so on. If you have any questions about how I solved this practice problem, please ask for clarification now so that you are ready for the test. Classify each function as odd, even, or neither. So first we need to understand. Odd is symmetric around the origin. Even is symmetric around the y-axis. And it's neither if neither of those are true. So in the upper left, if I rotate this around the origin 180 degrees, I do not get the same image back. So it is not odd. But if I flip this sideways around the y-axis, I do get the same image back. So this one in the top left would be even. Next, we can look at this top right. If I rotate this 180 degrees, I will get the exact same image back. If I flipped it over the y-axis, I do not get the same image back. Since this is symmetrical around the origin, that makes this one odd. Next, we can look at the bottom right. If we tried to rotate this around the origin, since it does not go through the origin, we would not get the same graph back. So this is not odd. If we tried to rotate it around the y-axis, you can see that this curve in the upper right would come over to the left side where there isn't one, and this curve down on the bottom left would move over to the right side where there isn't one. So this is not symmetrical around the y-axis either. This one would be considered neither. And if we look at the bottom right, This one does go through the origin, and if we rotated it 180 degrees, this line on the top right would go down to the bottom left where there is a line, and this line on the bottom left would come around and be on the top right where this line is. We would get the exact same graph back. Since this is symmetrical around the origin, we would declare this one to also be odd. If you have any questions about how to use a graph to determine odd, even, or neither functions, please use class time now to ask for further clarification before the test. Classify each function as odd, even, or neither. What you need to know is that for an odd function, f of x equals negative f of negative x. In other words, when you substitute negative f, you should get the exact opposite function. When it's an even function, f of x equals f of negative x. This graph is symmetrical around the y-axis, so your x value and your negative x value should have the same y value. That way, if you reverse them, it looks exactly the same. So if you get the same thing back when you plug in negative x, it's even. If you get the exact opposite back when you plug in negative x, then it's odd. And if it's a mixture, then it's neither. So for number 1, f of negative x equals 3 times negative x to the 4th plus 3. A negative x to an even power becomes a positive x. I plug in negative x, and I get exactly the same thing back. So number 1 is even. Number 2, f of negative x equals negative x cubed minus 4 times negative x. A negative x to an odd power stays a negative x. But a negative 4 times a negative x becomes plus 4x. I have the exact opposite, so this is odd. Number 3, f of negative x equals 1 over negative x squared plus 1. Well, a negative squared becomes positive. So this becomes x squared plus 1. That is exactly the same thing as we had for f of x. So this would be even for number 3. And finally, number 4, f of negative x would equal negative x squared plus negative x minus 3. A negative x squared becomes a positive x squared, plus a minus x becomes minus x, and the negative 3 stays the same. The x squared is the same, the minus 3 is the same, but the minus x is the opposite. This is a mixture, so it's not even, it's not odd, it's neither. If you have any questions about how to use equations to determine if a function is odd, even, or neither, please ask for clarification now so you'll be ready for the test. In each pair of graphs shown here, the values of function g are the values of function f multiplied by a scale factor. Express g in terms of f using function notation. So these are vertical scalings. So we would normally say that g of x equals k times f of x. And if I wanted to find k, I need to divide both sides by f of x. So if I want to find k, I can take g of x, which is the y value for g, and divide it by f of x, which is the y value for f. So in this top right, k equals the y value for g of x is negative 55. And the y value for f is negative 121. This can be simplified by dividing the top and the bottom by negative 11, and this becomes 5 over 11. So to express this in function notation, we would say g of x equals 5 over 11 times f of x. Now on the top right, we're going to do the same. K equals the y value of g. G is the solid line, so the y value is negative 13.6. The y value of f is negative 8. So now we can use a calculator. We have 13.6 negative divided by 8 negative, and that equals 1.7. So to write this one in function notation, we would say g of x equals 1.7 times f of x. Now if we look at the bottom left, we know that k equals the y value of g. G is the solid line, so the y value is negative 12.5. And that's divided by the y value of f, which is negative 50. And 12.5 negative divided by 50 negative equals 0.25, which is 1/4. So when we write this in function notation, we say g of x equals 1/4 times f of x. And in the bottom right, we know that k equals the y value of g, which is on this solid line, so that's negative 1.5 divided by the y value of f, which is on this dashed line, and that's 6. And negative 1.5 divided by 6 is negative 1/4. So now when we write it in function notation, we would say g of x equals negative 1/4 times f of x. If you have any question about vertical scaling, please use class time now to ask for further clarification before the test. Our last practice problem for the test review. Number 1. Write an equation whose graph is a parabola with vertex at 1, 4, and which opens upward. So remember, the generic parabola is f of x equals x squared. So for number 1, we now know that that parabola instead of having the vertex at 0, 0 is now at 1, 4. So this is a shift right 1 up 4. So now we would say f of x equals. We need to subtract 1 from x to have the shift to the right. So that's x minus 1 in parentheses squared. Now to shift it up by 4, we need to add 4 outside the parentheses. And this would be the equation for number 1. For number 2, now we have a parabola with vertex at 2, -3, and opens downward. So now we have f of x equals. To make it go from opening upward to opening downward, we need to reflect across the x-axis. We need to get the opposite of our original y values. So we're going to start with a negative. Now we've shifted from 0, 0 to 2, -3. So this has shifted right by 2. So now I need x minus 2 in parentheses, and to move down to -3 would be a shift down of 3, so we would subtract 3 outside the parentheses. If you have any questions about how I answered this practice problem or any of the practice problems, please use class time now to ask for further clarification so you're ready for the test.